a specialist from Manonmaniam Sundaranal University, and a PhD specialized in cloud computing from Anna University. He is recognized as a Zoho certified trainer with a cash reward of 25,000 by Zoho Corporation. He received SAP Award of Excellence from IIT Bombay with a cash award of 5,000. Outstanding Reviewer Award from Elsevier Computers and Electrical Engineering Journal. He is author of the book titled Fundamentals of Computing and Programming and also Fundamentals of LaTeX Programming, and published 13 book chapters uh, into Elsevier, Springer, and IGI Global. He is a Board of Studies member in Sri Sarda College for Women IT Department. He is recognized PhD supervisor for Anna University Chennai. 7 research scholars, 1 full-time and 6 part-time, are doing this PhD under his supervision. He is a PhD research coordinator. He has acted as a doctoral committee member for 3 research scholars. He acted as mentor for AICT approved online FTP programs, and also IIT Bombay approved a 5-week MOOC under AGC. He has published many national and international journal conference papers. He has served as reviewer for scientific journals as Springer, Elsevier, IET, and all. And he has guided 3 students and for research and development projects sponsored by Institute of Engineers, Kolkata, and 2 by TNSCST. He has presented 257 FTP seminars, webinars, and workshops. He has presented 2 international webinars. His research interests include cloud computing, Internet of Things, machine learning, and blockchain technology. Looking into his achievements, he is recognized as a Zoho certified trainer, acted as associate faculty or member uh, for online FTP conducted by IIT Bombay. He attended orientation sessions conducted by IIT Bombay. He received SAP Award of Excellence and Outstanding Reviewer award from Elsevier, Board of Studies member at Sri Sarada College of Engineering for Women. Continuously received 3 times Best Paper Award in National Conference on Innovative Computing, uh, and also active as a discussion forum and moderator. So we are proud to have you, sir. Taking over to you, you can take over.
Thank you. Sir, shall I start?
Sir, please.
Okay, thank you, sir. Thank you. Yeah, a very fine good afternoon. So, first of all, my sincere thanks to Dr. Kaliappan sir for providing such a wonderful opportunity to present a webinar on Open Nebula in cloud computing. So, sincere thanks to Mel sir too. So, the session which will be titled as Open Nebula in cloud computing, I will present a demo. Before that, just 2 slides for introduction to Open Nebula, then I will enter into demo. Yeah. So Open Nebula is an excellent tool. The greatest advantage of Open Nebula, even which supported for dashboard, that is GUI-based environment, as well as SELI-based environment, which supported for both command-based as well as GUI-based environment. So it's very much user-friendly one. So in that Open Nebula technology, which provides 4 excellent features. The first one, it's a lightweight tool. The tool was very lightweight because OpenStack and Eucalyptus, these are some of the middleware like Open Nebula, but these tools are heavyweight. But Open Nebula is a one and only middleware which is very lightweight and easy to install in any kind of operating system. And the maintenance was easy, then the operation as well as updation. These are the things are very easy in Open Nebula. Because of that reason, we are choosing Open Nebula for creating a private cloud. So Open Nebula, it's a private cloud software. Then another greatest advantage, which is very much flexible to user. It's completely open source. It's customizable to user. Whenever you need to modify the dashboard or console or any host or virtual machine, anything, you can customize for yourself. Then, which is robust. So every EVM is production ready. In addition to that, the Open Nebula which provide collection of machine images in this dumped operating system, which directly deploy on the Open Nebula. So it's another advantage. The tool is very much powerful. It's used to create private cloud and hybrid cloud too. All are very much familiar about the deployment model. There are 3 deployment models in cloud. The first one, which is called as private cloud. The second one, public cloud. Third one for hybrid cloud. Here, the Open Nebula is a tool which choose to create the private cloud environment. In addition to that, which support hybrid cloud too. So if needed, the private cloud tool Open Nebula, which merged with Amazon or Google Cloud or Microsoft Azure. So which provide private cloud as well as hybrid cloud opportunity. So another thing, it having very wide variety of distribution. So the updates are in a fine-tuned manner. The software was open source. Then there are collection of releases, currently for 72 releases within 8 years. So this is a Open Nebula architecture. This is a core architecture of Open Nebula. The Open Nebula software, like a normal VM, the Open Nebula software, which running on either kernel virtual machine or Xen hypervisor or VMware. So we need a node. We need a host machine in the bottom. So initially you can install Open Nebula frontend as well as KVM or Xen or VMware. So you need a tool. In the top of that, you can create the infrastructure management. So this Open Nebula itself, it can manage the storage capacity, then VM management, resource optimization, high availability, and business continuity. So Open Nebula automatically manages these set of things. Initially, you can configure the KVM or Xen or VMware, the node. You can configure a node. After configuring node, Open Nebula can manage your infrastructure. Then the later part, it's Open Nebula dashboard, which provide the VM creation, the interfaces for any API creation. It provides the elastic support for any kind of softwares. So the tool was very much fine-tuned, which having 3 layers. The bottom layer is a physical layer. It's our duty to install KVM, Xen, or VM. Any one of the tool, it's our duty. After installing the same, the Open Nebula dashboard, which manage infrastructure as well as cloud management. So after creating Open Nebula, after installing Open Nebula, the dashboard of Open Nebula, which will be called as the web interface of Open Nebula, which will be termed as Sunstone. The web interface of Open Nebula, which will be called as Sunstone, or one admin dashboard. Here, this dashboard, you can use either admin user or consumer or cloud architect. Anyone can log into cloud dashboard or Open Nebula web user interface. You can access all those tools. Yeah. The last part of introduction. So Open Nebula having wide variety of feature. The first feature, which is having cloud view, web view. So very user-friendly web portal. The Open Nebula portal was user-friendly one. Easy to, even a single click, you can create a host. Even a single click, you can create a VM and deploy the same. So the cloud view was very much fine-tuned one. Then the flow of Open Nebula for creating multiple VM application in a fraction of a second, and the rule-based management, the elasticity rules, it's managed in a proper way. So the flow was fine. Then the cost was very less. The entire tool was free. In addition to that, the tool was very lightweight. So even it run on commodity hardware. Even the Open Nebula tool, which run on commodity hardware. So there is no need to purchase a supercomputer or mainframe computer for installing Open Nebula. So Open Nebula is supported for 2 kind of interfaces, either command-based way or any API binding, which supported for both the things. In addition to that, Open Nebula, which provide 2 user interface. One is a GUI-based user interface, that is web interface. Open Nebula web interface, which will be named as Sunstone. The web interface of Open Nebula, which will be named as Sunstone. In addition to that, Open Nebula, which provide the command line interface, CLI. Even you can access Open Nebula via CLI or Sunstone. So both the way you can access Open Nebula. The deployment was very easy. You can deploy any software or any program in Open Nebula. It's very easiest one. Then it manage infrastructure and capacity management, same thing. Then it also supported for cloud federation or hybrid cloud. Then it provide a virtual center management. It also provide the admin control for managing virtual data center. Either you can create group of users or any delegate management for virtual resources or partitioning, isolation of cloud resource. So even admin can directly log into cloud portal or Open Nebula portal and manage the physical resources. Admin can log into Open Nebula portal and easily manage the physical resources. Then the flexibility, it's very much fine-tuned one. The extensibility, even you can integrate Open Nebula into AWS or Microsoft Azure or Google Cloud too. In addition to that, Open Nebula, it's very much flexible. It's supported for kernel virtual machine KVM, which supported for Sun hypervisor, which also supported for VMware or VirtualBox too. So it's supported for all kind of virtual machines. So many of the organization, they are using Open Nebula, few of them. So many of the users, Open Nebula having a wide variety of users. Many of the organization, if organization need a secure environment, they can create their own private cloud setup. So here, some of the organization, they are using Open Nebula. These are listed here. Yeah. Then I'm entering into Open Nebula tutorial, Open Nebula demo. So Open Nebula, it's a middleware software. All of them very much familiar about the term which is called as VMM. That is called as Virtual Machine Management. VirtualBox, Oracle, VirtualBox, or otherwise VMware. These are some of the virtual machine monitoring tool. Similar way, Open Nebula, it's one of the virtual machine monitoring tool. We choose to connect multiple systems. For example, in your lab, you are having 60 machines. In your lab, you are having 60 machines. So in the system number 1, I am installing Open Nebula front end. All other 59 system, I am install Open Nebula KVM or Sun or VMware. So in the front end tool, I will connect all the 59 system. Now each and every system holding 8 GB RAM. So all the RAM, processor, everything which connected together under a single dashboard, which is called as Sunstone. A Sunstone which integrate entire 60 machines into a single one. After creating this private cloud setup, whenever a user requests a VM, the Open Nebula which provide the VM service. So initially, the stage number 1 for installation of Open Nebula. So already I have installed. So just 4 slides I have played how to install Open Nebula. After that, I have played a live demo on how to work on Open Nebula. Okay. So initially, Open Nebula installation. The Open Nebula installation, it's supported for Windows, Linux, and all those operating systems. But anyway, I will choose for Linux. So I will install Open Nebula in Linux. My preference is Fedora or CentOS because these operating system which provide root access. These operating system which provide root access to client. So either use Fedora or CentOS. So here I have used CentOS. Okay. So step number 1. Here step number 1. This is for step number 1. This is for step number 1. So initially, the Open Nebula which need the repository. So I will check this base URL. This is a base URL. From that base URL, along with the key, from that base URL, the entire Open Nebula software is available in that URL. The entire Open Nebula software which is available in that URL. So actually the website was downloads.opennebula.io. Okay, downloads.opennebula.io. I will choose repository. Under that, my CentOS version is 7 and OpenNebula version is 6.0. Then I will choose the architecture is x64, 86 and 64-bit architecture. So I will open that website and I will choose that link and paste it here. So I will copy paste this command, sudo, then repository creation and end of text. So just I will open a terminal, or command prompt. I will paste this set of commands. So now my CentOS or Fedora OS or Red Hat OS, which pointing this repository URL. Whenever I download something, that also refer this mirror to. Okay, whenever I download the software, my operating system which refer this URL to. So this URL also, this website URL also added to my archive, or repository. Now, so after adding archive, after adding the repository, I will type the command which is named as, I will type the command which is called as install. Yes for if already installed, you can upgrade. So install EPEL release, EPEL release. So whatever supporting file needed for OpenNebula, which install with the help of this command. So install EPEL release, install EPEL. This is the first command. So initially you can set a repository. The second stage, you can type this command, install EPEL release. So entire thing was ready. Now the supporting files, my operating system as well as supporting file is ready for OpenNebula software. Now this OpenNebula software, which need a database. The OpenNebula software, which need a database for storing its user ID, password, groups, and access control rules. Entire thing is stored in a database. For storing it in a database, you have to install the database first. Any database, SQLite or MySQL or Postgres or Aurora, any database, it's your wish. Here I am installing the database which is called as MariaDB. That is MySQL. So MariaDB, which is similar to MySQL, so that's not a problem. So I will install MariaDB. So here sudo install MariaDB server and enable MariaDB and start MariaDB. So I can install the server and then I can enable the server and I can start the server. Now database is ready. Only 3 lines. Initially install database, then enable database, then start database. So now only just 3 lines, the database was installed and ready. Now I can create the password for database. I can create a password for database server. So here I will type sudo mysql _secure installation. So which will ask for root password. You can set the root password for your MySQL database. So initially you can install MariaDB which combines MySQL. So that's not a problem. Initially you can install MariaDB server. Then after that you can secure installation of MySQL, which can ask for root password. You can set the root password. Fine. So the step number 1, you can set a repository. After setting repository, the prerequisites of OpenNebula is installed with the help of the command EPEL release. After setting that, it's your duty to install MariaDB and enable it and start the service. After start the service, it's your duty to set the root password for database server. Now the root password was set. Now I will type this set of commands. Create database OpenNebula. So I have created a database for OpenNebula. I have give all permissions to that database. Then I have set the user ID 1admin and password 1admin. So I will create a database and give all those permissions and set user ID as one admin, password as one admin. So everything was okay. Now creating a database, then giving all those permissions and set user ID one admin and password one admin. Now my database was ready. Now you can install OpenNebula. Now the last stage, it's your duty to install OpenNebula. OpenNebula, which need 4 tools. The first tool, which is called as OpenNebula. The second tool, which is called as OpenNebula Server. The third tool is the dashboard called as OpenNebula Sunstone. Then the gateway, which is called as OpenNebula Gate. Then the architecture, which is managed by OpenNebula Flow. So M install OpenNebula, OpenNebula Server, OpenNebula Sunstone, OpenNebula Gate, as well as OpenNebula Flow. So even a single command which install all those supporting softwares of OpenNebula. So M install OpenNebula, OpenNebula Sunstone, OpenNebula Flow, OpenNebula Gate, and OpenNebula Server and Sunstone. So entire OpenNebula software was installed. That's all. So step number 1, you can set a repository. Step number 2, the requirement installation, which is named as Apple release. Step number 3, you can install a database and create a database. Then step number 4, you can install OpenNebula. Step number 4, you can install OpenNebula. Now, the OpenNebula installation was completed. Now, it's a last step. Please listen carefully. This step was very much important one. So now you can open that file. Sudo vim va editor /etc/1/1d configuration. This file comprising of 100 to 1000 lines. This file comprising of collection of lines. In the line number something 50 or 60, the file which directly connected with SQLite database. The file which initially connected with SQLite database. So I will place hash symbol in front of that. I will place hash symbol in front of these 2 lines. So which command SQLite database. Then the next line, these set of lines are commented. In front of that hash symbol is available. You can remove all the hash symbol. Okay. By default, OpenNebula which connected with SQLite database. Now we are installing MariaDB database, that is MySQL database. So you can connect MySQL database. So you can modify 1d.conf file and command SQLite database and enable MySQL database. Fine. So username as one admin, password as one admin, database name as OpenNebula. Now fine. Now configuration was completed. Now you can type this command. You can just type this command sudo. One second. So you can type this command sudo cat for viewing data in a file. So sudo cat variable /lib/1/.1/1_authentication. In 1_authentication is a file which holding Sunstone username as well as password. OpenNebula username password is fine, one admin and one admin. But Sunstone username password is here. Username is one admin, password, I think it's a very huge password, 75A70. Yeah, it's typical. So you can open that 1_auth file. It will display the data like this. So I have changed the password with the help of a single command. So I have changed the password with the help of the command echo one admin : one admin greater than, for writing it into file, tilde symbol .1/.1_authentication. So the file, otherwise you can open the file in the editor and then remove the password and type one admin. Okay. So my username was one admin and password was one admin. Now my Sunstone username was one admin and my Sunstone password also one admin. Now everything was completed. Now my OpenNebula was installed. and required softwares, required packages were installed. MariaDB server was ready. Sunstone dashboard is also ready. Now I will configure the username as well as password. That is one admin and one admin. So entire thing was ready. Now it's our duty to start the service. Before that, you can access. Before that, you can access this server in outside places. So each and every Linux server or Linux operating system which having their own firewall, So Open Nebula which skip the firewall. So because of that reason, you can add the port number of Open Nebula into that firewall. So I have typed the command firewall-cmd, add the port number. The port number of Open Nebula is 9869. The port number of Open Nebula is 9869. So I can add the port and reload the firewall. Now firewall which permit the port number 9869. So wherever you can access your IP address colon 9869, you can access the Open Nebula service. Now I will start the service. So before starting service, I need a node. Already I have installed Open Nebula front end only. I need a KVM or I need a send hypervisor. I need at least 1 or 2 nodes. So I can install node with the help of that command yum install Open Nebula node -kvm. So I can install KVM node. Okay. So initially front end was ready. Now KVM also ready. Initially front end ready. Now KVM is also ready. Now entire thing was completed. That's all. Now you can start Open Nebula. Start Open Nebula using command called the systemctl, system control, start Open Nebula and Open Nebula Sunstone. Enable is not required. Systemctl start Open Nebula, systemctl start Open Nebula -Sunstone. Now the Open Nebula which will be started. Now the Open Nebula service which will be started. Please see here. I will share my entire screen. So now I will open a browser window. I will open a browser window and then I will type my IP address, that is 172.168.196:9869. 172.16.20:9869. I will press enter. It's a dashboard of Open Nebula. It's a dashboard of Open Nebula software. I hope my screen is visible. Am I right?
Yes, sir.
Okay, thank you. So it will display the Open Nebula dashboard. So 172.16. It's my IP address. So 172.16.20.196:9869, which will display the Open Nebula dashboard. So these are the installation procedure of Open Nebula. Initially repository installation. After repository, you can install EPEL release, the basic requirement. After that, you can create MariaDB database. Then you can set username as well as password. Then you can install Open Nebula requirement, Open Nebula Sunstone, Open Nebula server, Open Nebula flow, as well as Open Nebula gate, as well as Open Nebula server. After installing the entire things, you can enable the firewall. Then you can start the service. In addition to that, it's your duty to install Open Nebula node KVM too. So installation was completed. The Open Nebula which enabled in the port number 9869, the firewall also enabled. Now I will open my dashboard. My username was one admin, so I will type one admin. My password is also one admin, so I will type one admin. Login. It's my Open Nebula dashboard. It's my Open Nebula dashboard. I have already created this set of things. Initially, I will explain this dashboard. After that, I am having a fresh dashboard. Before, I think, morning session, I will create a new Open Nebula for this demo. So I will open that in few seconds. Before that, This is a old dashboard of my Open Nebula. So this Open Nebula already which have one VM, one virtual machine is already available. 4 images in the sense 4 operating systems are already stored in that dashboard. 4.8 GB storage was already used. 3 virtual networks was created. 2 users, 2 groups, 1 user ID. Already allocated CPU and allocated memory was allocated. Fine. This is what entire dashboard. This is what my final output. A VM is created and VM is running. If you create any Putty Linux or VNC editor, you can open this and it will be show the show the output of CirOS or Ubuntu OS, anything. So the VM was running in a browser with the help of the VNC. Now I will create the new Open Nebula environment. So I will log out from here. I will entering into my new dashboard. So that is 205:9869 login. Yes, fine. So I will type the username as oneadmin and username as oneadmin, password as oneadmin. Keep me logged in. I will log in. So this is what my new Open Nebula dashboard. Yes. Initially, 2 users are by default. 2 users and 2 groups are available by default, but none of the host is created. None of the things was added. That's fine. So my step number one. This is the left hand side. This is the menu. So I start from the bottom. Settings is now not required. System. Already 2 users and 2 groups are available. 2 users, server admin and one admin. And 2 groups also available, users as well as one admin. Now I won't disturb the system. The first step of Open Nebula is create an infrastructure. Add KVM or send hypervisor. So first step was create the node. So I will create a node. I will go to infrastructure. I will open cluster. Already default cluster is available. So I will use the same default cluster here. Then I will entering into hosts. No node is available. So I will add the node. So I will click on host, KVM. KVM was added into default cluster. Name of the host is localhost. So the same machine I am installing KVM also. Otherwise you can enter the IP address. Okay. Here same machine I have installed KVM. So I will add that host, create. The host was added. Wait for a few seconds. Then it will be refreshed. I will refresh. Yes, on. Now it's turned on. Initially init, now it's turned on. It's having 400. Then allocated memory is 7.5 GB. So the host is ready. Now I will add one more host for virtual machine migration. So local host dot local domain. Localhost dot local domain. I will create this host too. Init. In initialization, the status is initialized. Please wait for a few seconds. Refresh. Yes, status also on. Now I will create 2 hosts. If you are having multiple machine, you can add multiple hosts too. For example, in my machine 172.16.20.196. In that machine also I am having a KVM. So I can create another host. But this machine I am not enabling host to outside. So it not works here. So whenever needed, I can permit for I am enabling secure shell. Now I am not enabling SSH. So these 2 servers only it will be added. Okay. If you are installing node, you can enable secure shell. Then only the node was added anywhere. Okay. Now the host was added. Now 2 hosts is available. One is localhost. Second one localhost.local domain. Now everything works fine. Now you can create a network. The second level, you can create a virtual network. So you can go to virtual network and click this plus symbol, create. So you can create virtual network for your VM. So I have named it as VNet. I have named my virtual network as VNet. If needed, you have give a configuration. This is my new virtual network. So already my host also grouped to default cluster. So VNet also grouped into default cluster. Okay. If needed, you can create your own cluster too. So default cluster. Now you can go to the second tab, CONF, configuration. Second tab, configuration, CONF. So the network mode is bridged mode. Okay, there are a collection of network mode is available. Here you are using a network mode as bridged mode. Then the bridge name is BR0. The bridge name is BR0. Then address. You can provide the IP address. So I will provide the IP address 172.16.20.230. Number of machines, I need 10 machines. 30, 31, 32, 33. So 10 IP addresses are allocated. Okay. Then security, QoS, and context, I won't modify these set of things. Initially, I can enter my virtual network name. Next, I can enter into configuration. That is, I'm choosing bridge network. Then I have type BR0. Then address, IPv4 addressing. I will choose the starting IP address is 172.16.20.230. Then the entire size of my network is 10. So 10 IP addresses allocated or assigned in my network, virtual network. Create. Yes. So my virtual network was created. The owner of the virtual network was one admin. It's also under the group one admin. Then there is currently no reservation. Nothing, no IP address was reserved, but it's having 10 IP addresses. 0 IP address was reserved, having 10 IP address. So entire thing was displayed. If needed, you can click on this. It view the entire detail, the read write permission, owner permission, bandwidth permission, everything was displayed here. So now I have created VM. So initially I can create an infrastructure. After that, I have to create a network. The first stage, I have to create an infrastructure. The second stage, I'm creating the network. The stage 3, the third stage, it's a storage creation, data store. So you need 3 different type of data store. The first data store is file data store. Second one is image. Third one is system. So I will create a new data store. Create the data store for my machine. So something K7 underscore files. So I will choose file shared mode. Okay, choose file shared mode. So this used to store my images or system or files. It's a files. So I will choose files. Create. Similar way, I will create my second data store. K7 underscore images. I will choose images. Create. I will create another data store. K7 underscore system. So I will choose system data store. Create. So currently I have created 3 data store, three data storage environment. All the files are stored in files data store. The operating systems are stored in images data store. All the system oriented files are stored in system data store. Okay. So I have created 3 type of data store. One is a file data store. Second one is an image data store. Third one is a system data store. File data store which holding all the additional files. Image data store which holding operating system. System data store which holding system files. Now data store is ready. Now images. So currently no images are available. Image in the sense dump operating system. So I can go to Google. I will type the image, SIR-OS image, a tiny OS that is called a SIR-OS image. So download SIR-OS image from Get OpenStack Images. Here, SirOS image download page. I will click here. Here, I will choose the version for 6.1. The image was available. I will download the image. IMG file. So already I have downloaded. Anyway, I will paste it into different folder. One. So save the file. So it's a very tiny image. So the image was downloaded and saved here. Similarly, I have downloaded another one operating system. There are a collection of dump operating systems are available. I will choose Ubuntu image. I will choose Ubuntu based image, minimal version, releases. I will choose the focal release. I will choose any one of the version. Then I can download that image file. So currently I have downloaded one for SirOS, the second operating system for Ubuntu operating system. Currently I download one for SirOS, the second operating system was Ubuntu operating system. The two images were downloaded. Wait for a few seconds. The download is under process. Now these two files were downloaded. Download was completed. Now you can go to your dashboard and then click on Add, Create, the name of the image. So SirOS. I will type the same name, SirOS. Then operating system image. Then I will choose K7 images data store. Then path and URL. I will choose upload option. Choose a file from E:. I think desktop. Desktop, there is a folder called as K7. Inside that, the folder called as 1. I will add SirOS. The file was uploading. Create. Wait for a few more seconds. The SirOS was a very tiny OS. So the image was uploaded into K7 image data store. Yes, now ready. The OS was ready. Similarly, I can upload the another OS. The second OS was Ubuntu. Ubuntu. Choose the same image, then upload. Then choose the URL, Ubuntu folder. Then I will create. This file was a little large, so it takes few seconds. So initially I have uploaded SirOS image. Next I have upload Ubuntu image. So image is a dump operating system. So in the top of my infrastructure, this operating system which will be loaded. Yes, now two operating system was loaded in my data store. In that storage, initially you can create a data store. The data store which need three different data stores. One is a file data store. Second one is an image data store. Third one is a system data store. In that image data store, I have uploaded Ubuntu operating system image as well as SirOS operating system image. SirOS operating system image. Now data store was ready. Files. Currently, I won't upload any files. Now it's not required. Marketplaces, apps, these are not required for now. So storage was completed. Initially, I have created infrastructure. Under that, I have added two hosts, cluster and host. After that, I have created virtual network. So 10 IP addresses was added. After that, I have created 3 data stores. Now I have uploaded 2 virtual machine images. Now I have uploaded 2 virtual machine images. Now I am entering into the last part, templates for VM creation. Templates for VM creation. Click on create a new template. My new template named as K7 _ SirOS. I will choose the hypervisor as KVM. I will choose the hypervisor as KVM. Memory as 1 GB. Physical CPU as 1 GHz. Virtual CPU also 1 GHz. Yes, fine. Now I will enter into second tab. Name SirOS. choose hypervisor as KVM, then 1 GB storage and virtual CPU 1 and physical CPU 1. Now I am entering into second part, storage. The SirOS and Ubuntu OS are available. I will choose SirOS. Now it's added in the blue color. I will choose SirOS, so SirOS was added. Then I will click on network. Click on network. Already VNet is available. I can click VNet. So VNet was added. Among that 10 IPs available, 1 IP is assigned to SirOS. Now OS and CPU, input, output, actions, context, scheduling, and VM group. You won't touch this. So general, you can type the name of the virtual machine template and KVM and choose memory, CPU, and virtual CPU. Then go to storage, you can choose your operating system. Go to network, you can choose your virtual network. Then you can click create button. Now VM template is ready. Now VM template is ready. Similar way, I can create VM template for Ubuntu. So create K7 underscore Ubuntu. Hypervisor is KVM. Memory is 1 GB. Processor is 1. Virtual processor is 1. Then I will entering into storage. I will choose Ubuntu operating system. Network, I have choose my VNet. I can click create. Now I am uploading two images. The one is a Ubuntu image, second one is a SirOS image. The two images are mapped to my VM templates. Now template is ready. The two images are mapped to my VM template. Now the entire template was ready. Now it's your duty to start the VM. So you can click on the instance and VM. Click on the instance and VM. Then you can click on create button and I will choose SirOS VM. I will choose SirOS VM and create. Now VM was creation was in process. Status is pending. Please wait for few more seconds. VM creation is under process. Please wait for few more seconds. The IP address assigned was 172.16.20.230. You can refresh. Yes, VM is running. VM is initially bending and boot and initialize and running. Now here the VM is ready. You can type this IP address in any VNC. You can type this IP address in VNC. You can open SirOS. You can type this IP address in any VNC, any virtual machine, or any virtual box. You can view this too. I can download some VNC, putty VNC. I think Putty Linux is available. Putty Windows. Download Putty for Windows. You can, I think Windows installer is available. Anyway, you can download this. So anyway, this is what the VM was created. Similar way, you can click this link. Please see here, the owner having use and manage service. Then I can install Putty first. So here the IP address of that machine is 172.16.20.230. The start time is this. The deployment ID is this. The entire marketplace. Then I can view the capacity, the storage capacity and real memory usage. Then storage, the storage usage. Currently it's not used. Network allocation usage. The snapshot of my operating system. Take a snapshot. So it can take a snapshot of currently it's in progress. So it can take a snapshot. Placement, it's running in localhost.local domain. It's running in localhost.local domain. Then action. Currently there is no action. If needed, you can add action for real-time verification. configuration already which running on the port number 5900. The type of client is VNC client. The type of client is VNC client. 1 second. Then the templates, this is a template for this operating system. This is a log file of this operating system. Entire operating system works fine. Whenever you can install, for example, I'm having something called as Linux system. In that Linux system, you can type, if you are having a Linux machine, you can type yum install VIRT-VIEWER virtual machine viewer, virtualization virtual machine viewer, and then you can type VIRT-VIEWER. Then which will open the virtual machine, the entire CirOS operating system which is open in that viewer. Okay, currently it's for Windows. Here there is no VNCs available. So these two commands are used to view the virtual machine in Linux operating system. Now I will go to my machine. I can create the another VM. I can create the another VM. Why it's not installed? I can create another VM for Ubuntu operating system. For Ubuntu operating system, I can click create. So the IP address was 172. Please see here, the IP address was 172.16.20.231. The second IP address was assigned. It's bending. Please wait for a few more seconds. It's prolock. Wait. Yeah. Now my VM was running. Both the VM was running. If you are having VNC viewer, I think if putty is installed, VNC viewer is ready. For Windows, putty is not installed. Anyway, if needed, you can run the same in CentOS. CentOS, you can type these two lines. Yum install VART viewer. Then you can type VART viewer. Then you can view the Ubuntu dashboard. You can view the Ubuntu dashboard as well as you can view the CirOS dashboard. So this is what with the help of the Open Nebula, you can install the VM. So I can repeat the same again. So initially you can set a repository. Step number 1 for set a repository. Step number 2 for required files were installed. Step number 3 for create a MariaDB database. Next, you can set a root password for MariaDB database. Then you can create an Open Nebula database inside MySQL and grant all permission and set Open Nebula username as OneAdmin and password as OneAdmin. Then you can install Open Nebula Server, Open Nebula Sunstone, Gate as well as Flow. Now you can configure the file. Initially you can command SQLite and enable MySQL. And for viewing the password, you can type sudo cat var/lib/1/.1 authentication file. The password is very large, so I can edit this file using this command. So I will change the password into OneAdmin. Now the enable firewall, because firewall which block the port number 9869. So for enabling firewall, I can type firewall-cmd at the port number 9869. And then I can reload my firewall. After that, you can install Node KVM too. So install Open Nebula Node KVM. Then you can start the lib virtualization service. Now, you can start Open Nebula. So systemctl start Open Nebula space Open Nebula hyphen sunstone. Then systemctl enable Open Nebula and Open Nebula hyphen sunstone. So now the Open Nebula was started in the port number 9869. So in the browser, you can type your IP address or localhost colon 9869, which will open a dashboard of Open Nebula. So you can enter the user ID one admin and one admin, then which open a Open Nebula dashboard. Yum install virtualization viewer, which used to view the virtualization output, VNC output. So in addition to that, Open Nebula which also accessed via console using these commands, one user show, one user hyphen h. Then the entire dashboard which viewed in localhost colon 9869. The username is one admin and password is also one admin. So this is the entire dashboard of Open Nebula. So here I will start from bottom. Here I am start from bottom. Initially cluster, I have used default cluster. Then after that I have add host. So initially host is 0. After that I have add 2 hosts and 1 VNet and 6 data stores. Already 3 data stores is available. I have created 3 data stores. So host, so localhost and localhost dot local domain. So 2 hosts were added. Then network, I have added virtual network VNet and I have set the addresses as 172.16.20.230 to 10 IP addresses. Then after creating VNet, you can create a data store which need 3 data store, one which is called as file data store, second one which is called as image data store, the last one which is called as system data store. File data store which holding all those files, image data store which holding all those operating system data store which hold all those system oriented files. After creating this data store, you can upload images. So I'm entering into Google and search for CirOS and Ubuntu image, and I can download that image and upload here. After that, I'm entering into VM template. I have created one VM template for CirOS, another one VM template for Ubuntu. Based on that VM template, you can create n number of services. I can create another one service for CirOS. So VM, you can add, you can create CirOS. I can create another template for CirOS. So you can create n number of services. You can, the entire processing, entire RAM process, entire system process, entire network management, everything which will be displayed in the dashboard. So allocated CPU, allocated memory, and storage used, images used, and 2 images, and number of VM created, number of users, entire thing which will be displayed in an Open Nebula dashboard. So this is a very lightweight database. It's very easy, very much flexible. Entirely the software was free. User can access anywhere in the world. So you can download private cloud and install, Open Nebula, and install in your own machine and create a private cloud setup for your college or for your home or for your organization. Anything you can create in a fraction of a second. It can manage any data. But even a commodity hardware, a normal commodity hardware is enough for managing this Open Nebula too. So these are the small overview on Open Nebula, introduction to Open Nebula, and how to manage, install Open Nebula, and how to create a simple VM in Open Nebula dashboard. Any questions from student side? Students, you can try it during free time. So if you have any queries, please inform to Kalipan sir. Otherwise, you can message me. I will help you. Okay, fine.
Sir,
please.
Can we create a big server with high hardware specification? That means how to create a big server to handle big data using our lab system, 60 system. One system having 32 GB RAM, 1 TB hard disk. So combine all those things. So can we convert it into a big server with 1000 GB RAM and 60 TB hard disk storage using this tool,
Open.
sir?
Yes, sir, sure. So actually, this dashboard, in your college, you are having 60 machines like that. So initially, you can install this front end in any one of the server, any one of the good configuration machine, front end. After that, all other machine, you can type this one command only. This command was node installation, KVM node installation. All machines are node. Only the first machine is the front end. So you can install this node. After installing the same, you can enter into this host. You can add all those KVM hosts, all those KVM host IP address. So all the machines are connected together, and your dashboard is source. It's having all those hosts are displayed. Allocated CPU. Currently, I have 2 CPU. So allocated CPU, the 2 CPU processing power, 400 gigahertz, 400 gigahertz, it's merged together. I have used 300. Similar way, I have 7.5 GB, 7.5 GB. So totally 15 GB, 2 machines. So 2 machines memory was merged. Similar way, your 60 machines machine processing power and memories are merged together and displayed here. So then whenever needed, you can create a data store, you can create template, everything fine. At last, you can create a VM. Depends on user. You can allocate RAM, you can allocate memory, you can allocate virtual CPU, everything. You can create a VM. This VM is running. Currently, the VM is running. Whenever needed, you can install the real VNC viewer. I think this is a software, real VNC viewer. You can install this software and enter this IP address 172.16.16.20.232. So you can access this service wherever in the world. So it's acting like a public cloud. But one and only security is your user ID as well as password, your public IP address is provided. So if it's private IP address, if currently my 172.16.20.232 is my private IP address. So I have connected 2 machines in my college. So these machines are accessed by inside our college LAN network only. So if needed, you can provide your public IP address. Public IP address not needed for all the node. Public IP address only you can provide for your front end only. So all the 60 machines are connected. So you can the private cloud is ready with the help of OpenNebula. If you are using OpenStack or Eucalyptus, which need a front end server was higher end server was needed for front end development. But OpenNebula is lightweight. Even normal PC, even P3 machine is enough for installing OpenNebula. So you are having 100 P3 machines. So OpenNebula which merge 100 P3 machines and create an excellent private cloud setup. So it's supported for olden age machine too. So it's the advantage of OpenNebula.
To set up LAN for the 60 system, I need to create a network.
It's mandatory.
It's mandatory.
The local area network is mandatory.
So after setting, after all the settings, can I create a high-end server as an instance? Right?
Yes, correct. So this is advantage. You can create a higher end server. For example, 500 GB in one machine. It's the advantage of OpenNebula. So in otherwise, if needed, you can split into 100 GB, 100 GB, 100 GB, or 5 machines too.
In that instance, so we can store or we can run any application like big data,
Hadoop or MATLAB, anything it can run on that machine.
Deep learning also.
Yes.
Okay.
Colab also, the Jupyter also supported that.
Thank you. Thank you very much, sir.
Thank you, sir. Thank you. Thank you, sir. Thanks for providing such a nice opportunity. Thank you, sir. Thank you. Thank you, students. Thank you all.
Thank you, sir. Thank you all.
As we draw the curtains on this enlightened webinar, on behalf of the Department of Artificial Intelligence and Data Science, I am very happy to propose the vote of thanks for the webinar on Open Nebula and cloud computing. I must express my deep sense of appreciation and gratitude to our respected resource person, Dr. Kesav Raja. Thank you, sir, for your time and knowledge you shared with us.
Okay, students, before leaving, how to fill the feedback form and assessment.